Hi everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3 for October-November 2022, and the code is 9709/32. Let's get started. Okay, so for question number 1, solve the equation 2 to the power of 3x minus 1 equals to 5 multiplied by 3 power 1 minus x. Give your answer in the form ln a over ln b, where a and b are integers. Okay, so now first of all, we copy the question. Right, so now we need to take ln both sides. So you are getting ln 2 to the power of 3x minus 1 equals to ln of 5 bracket 3 to the power of 1 minus x. So now we have the formula of ln AB equals to ln A plus ln B. Because of the right side, you have ln of 5 times 3 power 1 minus x. So by applying this formula, ln AB is ln A plus ln B, we will split it into two terms. The first term is ln 5, then followed by plus ln of 3 to the power 1 minus x. Okay, so now we have another formula, which is ln A to the power of B equals to B ln A. So for the left hand side, right, the power of 2, which is a 3x minus 1, will be brought down according to the second ln formula here. So I will get 3x minus 1 times ln 2 equals to ln 5 plus bracket 1 minus x multiplied by ln 3. So since the question asks for solving the equation, means that we need to find the variable, which is our x here. So now we need to do the expansion for the first term on the for the term on the left hand side, and also for the second term on the right hand side. So now when I do expansion, I will be getting 3x ln 2 minus ln 2 equals to ln 5 plus 1 times ln 3 is ln 3, then minus x ln 3. Okay, and then for the term which consists of x, we should group it on one side. So means that I will be moving the x ln 3, negative x ln 3, from the right side to the left side. So I will get 3x ln 2 plus x ln 3, then right hand side equals to ln 5 plus ln 3, and this negative ln 2 will be moved to the right side. So I will be getting plus ln 2. Okay, so for the left hand side, the common term, which is the x, will be taken out. I will get 3 ln 2 plus ln 3 after you factorize the x. And for the right hand side, we may combine all the ln using the first formula. Therefore, I will be getting ln 5 bracket 3 bracket 2. Okay, so from here to get the x, it will be ln of 5 times 2 is 10, 10 times 3, it will be 30. Then divided by 3 ln 2, again I can use the formula ln A to the power B. So I will get ln 2 cubed plus ln 3. Okay, and now the questions must be, the final answers must be in terms of ln A over ln B, where A and B are integers. It means that now I need to simplify my denominator. So I will be getting ln 30 over ln 2 cubed is 8. Okay, because of the plus, by using the first formula here, okay, the first ln formula, you need to multiply 8 with the 3. So at last, I will be getting ln 30 over ln 24. That is the solution of number 1. Okay. So that's all for the question 1. Now question 2. The polynomial 2x cubed minus x squared plus a, where a is a constant, is denoted by px. It is given that 2x plus 3 is a factor of px. A, find the value of a. Alright, so first of all, we will let px be 2x cubed minus x squared plus a. Now, according to the factor theorem, if 2x plus 3 is a factor, that means when you let this 2x plus 3 be 0, alright, 2x plus 3 be 0, our x will be negative 3 over 2, which means p of negative 3 over 2 will be 0. This is what we get from the factor theorem. So now you need to replace the x by negative 3 over 2. So left hand side will be 0 because it's p of negative 3 over 2. Right hand side, as long as you see the x, you have to replace it by negative 3 over 2. So I will have to write 2 bracket negative 3 over 2 cube minus negative 3 over 2 squared, then plus a. Okay, so from here, do the expansion. 0 equals to cube of negative 3 over 2 multiply by 2, you'll be getting negative 27 over 4. Then negative square of negative 3 over 2, it will be 9 over 4, then plus a. So from here, when you move these two terms to the right side, to the left hand side, and plus together, at last your a will be 9. That is the solution for the first part. Okay, so now b, when a has this value, solve the inequality px less than 0. So now we need to rewrite our px first. So our px becomes 2x cubed minus x squared plus 9. So I will rewrite my px. Okay, since we know that 2x plus 3 is a linear factor, and now your px is a cubic equation, which means we need to solve the other two factors by using the polynomial division. Okay, so I will carry out the polynomial division first. So 2x cubed minus x squared plus 9. Okay, now for the polynomial division, after the x squared is supposed to be x, so I will write 0x. I will add on this term, then followed by constant, and divide by 2x plus 3, because the 2x plus 3 is one of the factors. Alright, so from here we need to multiply a term with 2x in order to get 2x cubed. Therefore the term must be x squared. So I will write x squared here. So x squared times 2x, I will be getting 2x cubed. The x squared times plus 3, it will be plus 3x squared. Alright, then you minus. So the first term will be getting 0. Second term minus x squared minus 3x squared. It will be minus 4x squared. And then bring down the 0x. Now, to get minus 4x squared from 2x, so we need to multiply 2x by negative 2x. So negative 2x times 2x, you'll be getting negative 4x squared. Then negative 2x times plus 3, it will be minus 6x. Okay, then minus. So now first term will be 0. Second term is 0 minus 6x. You'll be getting 6x. Then bring down the plus 9. Now, here we need to multiply by plus 3. So plus 3 times 2x, it will be 6x. Plus 3 times plus 3, it will be plus 9. So then you'll be getting the 0 remainder. So once you get 0 remainder, I will rewrite my px less than 0. Okay, so because we need to solve this inequality, is basically 2x plus 3 multiplied by the quotient, which is x squared minus 2x plus 3 less than 0. So from here, you are getting a quadratic equation, or quadratic, I would say quadratic factor. Alright, so we need to solve this by factorizing the quadratic factor. So now, what we need to do is, you may try using calculator, or probably we can just check our discriminant. Okay, so I will let x squared minus 2x plus 3 equals to 0. Because I need to try to get the factors from this quadratic equation. So now my a will be 1, my b is minus 2, my c is 3. So from here, the discriminant b squared minus 4ac, it will be negative 2 squared minus 4 times 1 times 3. So now, this is basically 4 minus 12. My b squared is negative value, so minus 8. So now, since your b squared minus 4ac is negative, which means there's no root for this quadratic. Okay, so you cannot factorize it. So no root, therefore always positive. Okay, this quadratic is always positive. So what we do here is, I will say x squared minus 2x plus 3 is always positive. Right, so since this quadratic is always positive, now you multiply by 2x plus 3 and it will be less than 0, which means our 2x plus 3 must be less than 0. So at last, the x will be less than negative 3 over 2. Right, so this is how we solve the inequality. Now, question 3. The equation of a curve is y equals to sine x sine 2x. The curve has a stationary point. So stationary point means that dy dx equals to 0 in the interval x between 0 and pi over 2. So find the x coordinates of this point, giving your answer correct to 3 significant figures. Alright, so now the keyword is stationary points, means that we need to get the dy dx equals to 0. So now, first of all, we rewrite y equals to sine x sine 2x. So now you need to differentiate this using the products rule. Okay, so dy over dx. So you may write down u equals to sine x, v is sine 2x, then your du dx will be cos x, and dv dx equals to differentiate sine, you get cos, remain the 2x, differentiate 2x is 2. So from here, according to the products rule, the formula is u dv dx. So now sine x 2 cos 2x plus v du dx. So cos x multiplied by sine 2x. Okay, so stationary point means dy dx equals to 0. So now let left side be 0, then right hand side. Okay, so when you check the solution here, you have sine 1x, you have cos 2x, then you have cos 1x and sine 2x. So to solve the equation, right, we change the 2x, the double angle formula, into single x, alright, which means in terms of just x and no longer 2x. So now from the cos 2x formula, or probably we can write cos 2a equals to 2 cos squared a minus 1. Okay, I will use this formula to simplify, because we have the cos in the second term. That's why I will choose a 2 cos squared a minus 1 instead of the other two equations. Right, so now from here I will change it to 2 cos. Okay, now you have to be careful, there is a 2 outside, therefore I should multiply by another 2 first. So here 2, then the cos 2x itself, when you compare, my a is x, therefore I will change to 2 cos squared x minus 1. Okay, then now plus cos x. So for the sine 2x, I will be using the formula of sine 2a. So we have another formula, sine 2a is 2 sine a cos a. So when you compare, the a is the x now. So I will be getting 2 sine x cos x. Okay, so from here, you can factorize the common term, which is 2 sine x. So here 2 sine x. So now I will write 0 equals to 2 sine x, then 2 cos square x minus 1. So since we have factorized the 2 sine x from the second term, which means you still have the cos square x, because cos x is cos square x. So I will get plus cos square x. Alright, so now rewrite the 2 sine x. Then 2 cos square x plus cos square x, it becomes 3 cos square x minus 1. Okay, so when you need to solve means that you are getting the x values. So now when there are 2 brackets, okay, or multiplication of 2 terms, and the answer is 0, which means one of the terms must be 0. So I will be getting 2 sine x equals to 0, or 3 cos square x minus 1 equals to 0. Alright, so now do not forget about the interval, your x between 0 and half pi. So now here 0 and half pi. So when 2 sine x equals to 0, which means sine x equals to 0, and hence now when you refer to the sine graph, so this is our sine graph. So the graph will be 0 at 3 points. So 0, pi, and 2 pi. Right? So I will write 0 equals to 0, x equals to 0, pi, and 2 pi. And then for the second term, cos square x equals to 1 over 3. So now cos x will be plus minus square root 1 over 3. Okay, or 1 over square root 3. But then now, when you check the interval, okay, so now your x between pi 0 and pi over 2. So that means for the first solution, your x 0 cannot be accepted because there's no equal sign. The 2 pi cannot be accepted. Pi also cannot be accepted. Means that all this must be ignored. Right? So from here, all this omitted. Alright, so no solution. So from here, from the second solution over here, cos x equals to plus minus 1 over square root 3. So from the quadrant, we know that as long as it is between 0 and half pi, which means it is in the first quadrant, your cos x shouldn't be negative. So from here, we will just write cos x is 1 over square root 3. Okay, and now use the calculator, change the mode to radians. You'll be getting 0.955. So that is our solution. Okay, for this question. Alright, so now question 4. Express 4 cos x minus sin x in the form r cos x plus alpha, where r greater than 0 and alpha between 0 and 90 degrees. That's the first part of the question. Then second part is state the exact value of, okay, now when you solve this, you basically need to state the exact value of r and give alpha correct to 2 decimal places. So it means that this question only consists of one part, which is expressed in r cos x plus alpha. So r must be exact and the alpha will be 2 decimal places. So now we rewrite 4 cos x minus sin x equals to r cos x plus alpha. Okay, now when you look at this, when this is r cos, right, first term must be cos, so that's our coefficient for the cos x is a equals to 4, and then the b will be 1, because when we do expansion for the cos x plus alpha, you'll be getting the minus for the second term. Therefore, your b is 1. So now, for getting the r, okay, the r is basically square root of a squared plus b squared. That means we are getting 4 squared plus 1 squared, and then it is square root 17. Okay, and then the alpha value will be inverse tangent b over a. So b is 1, a is 4. So inverse tangent 1 over 4 in degrees, because your alpha is in degrees, it will be 14.04 degrees. Okay, so at last, 4 cos x minus sin x will be square root 17 cos x plus 14.04 degrees. So that's the solution for 4a. Okay, now for B, hence. Hence means use a previous answer, means now you have to solve using this square root 17 cos x plus 14.04 degrees. Okay, use that results to solve for cos 2x minus sin 2x equals to 3 for x between 0 and 180 degrees. So now I will copy the question first. Okay, then now you compare the left hand side. 4 cos 2x minus sin 2x. It is similar to the previous step or previous working. Okay, it's just that now when you compare, this is 1x. Here becomes 2x. Alright, so if here 1x change to 2x, which means we have to change the x inside the cos as well into 2x. Alright, so I will change the left hand side of the b into square root 17 cos bracket 2x plus 14.04 degrees. Okay, so you must change accordingly. So now square root 17 cos 2x plus 14.04 degrees equals to 3. So first of all, we have to move the square root 17 to the right hand side. Then you'll be getting cos 2x plus 14.04 degrees equals to 3 over square root 17. Okay, then now from here, you are getting 2x plus 14.04 degrees, and the initial interval of the x is from 0 to 180 degrees. So now I will get the new interval. So your x from 0 to 180 degrees. So when 2x, it will be from 0 to 360 degrees because you multiply by 2 and then add with the 14.04 degrees. So now the interval will be from 14.04 degrees until 360 plus 14.04 degrees. That means it's 374.04 degrees. So now we can accept the values in this interval. Okay, so now get the basic angle from the calculator. So 2x plus 14.04 degrees is the inverse cos of 3 over square root 17. Then 3 over square root 17. So the basic angle is basically 43.31 degrees. Okay, I make it to 2 decimal places first because later we need to divide by 2. So now for your information, we are solving cos. So the cos is positive for first and last quadrant, which means both of these will be 43.31 degrees. Okay, here 43.31 degrees. Now by looking at this interval means that now we can accept 43.31 degrees because it's greater than 14.04, and then we can accept up to 374.04 degrees, which means the next value is going to be 360 degrees minus 43.31 degrees, and it will be 302.69 degrees. Oh, sorry, it is 316. Okay, 316.69 degrees. Okay, so now next step is to move the 14.04 degrees to the right hand side. So you have to minus the angle from 14.04 degrees, and then you'll be getting 29.27 degrees, and the other one is 302.65 degrees. Okay, and at last divide the two angles by 2. So you will be getting 14.6 degrees and followed by 151.3 degrees, correct to 1 decimal place. Okay, so that is how we solve the part B. Okay, now question 5. Solve the equation z squared minus 6iz minus 12 equals to 0, giving the answers in the form x plus iy, where x and y are real and exact. Exact means no decimal. Okay, so now rewrite the equation. So when you need to solve this, since this is degree 2, I will say that this is a quadratic equation. Then now I'm going to solve this using quadratic formula. So the coefficient for z squared is 1, therefore my a is 1. The coefficient for z is minus 6i, therefore my b is minus 6i, and then my c is going to be negative 12. Okay, since now your equation in terms of z means when we solve using the quadratic formula, instead of x, we have to write z. So the formula is minus b, so minus negative 6i plus minus square root of b squared. So the b squared is minus 6i squared, then minus 4, a is 1, c is negative 12 over 2a, a is 1. Okay, so now when you simplify, so minus minus 6i, it will be 6i plus minus square of minus 6i is basically 36i squared. Then minus 4 times 1 times negative 12, it becomes plus 48 divided by 2. Okay, for your information, I square is minus 1. So now inside the square root, it will be negative 36 plus 48. So you will be getting square root 12. Okay, it's same as 48 minus 36, then over 2. So now simplify this result. It will be 6i over 2. I'm getting 3i, then plus minus, there's a minus here, square root 12 over 2. The square root 12 is basically 4 times 3, okay? Square root 12 is square root of 4 times 3. So square root 4 times square root 3. Therefore, I'm getting 2 square root 3. So now if here is 2 square root 3, then divided by 2, at last it will be just square root 3. Okay, so normally we will leave our answer in x plus iy form, means that real parts first. Then I will write plus square root 3, just write square root 3. Then plus 3i, or another one is negative square root 3 plus 3i. So these are the two roots for this quadratic equation. Okay. Now B, on a sketch of an Argand diagram with origin 0, show points A and B representing the roots. Okay, so we have found the roots just now. These are the two roots. So one of them will be A, another one will be the points B. So now you need to sketch it on the Argand diagram. Okay, so basically you draw the axis first. Alright, so now I found square root 3 plus 3i. So means that, let's say here is square root 3. Okay, then here is 3i. So square root 3 plus 3i is my first term or first point. Another one is the O. Here is the O. Okay, show points A and B. So I let this be points B. And then another point is minus root 3 plus 3i. So it means that the real part is negative root 3. And the imaginary part is 3. Let's say here is the A. Alright, so this is our result. So because you just need to show the points. So we have found A, B, and the O. Okay, so now see, find the exact modulus and argument for each root. So now your roots are root 3 plus 3i and minus root 3 plus 3i. So now modulus of root 3 plus 3i, it will be square root of square root 3 squared plus 3 squared. So it will be square root of, this is 3, here is 9. I will, because of exact, right? So no decimal place, I will get square root 12. So, and again, square root 12, just now I have shown you how to simplify. It will be 2 root 3. So leave your answer in the simplest form. Now, next, find the argument. So, argument of root 3 plus 3i. Okay, so for this case, I need to draw the Argand diagram, or probably no need to draw, you can just refer to here, to the previous part, which means it's like this. Alright, so the argument is in first quadrant. This is the argument. Alright, so now I will just use inverse tangent of 3 over root 3 to get the argument. So it will be inverse tangent of 3 over square root 3. So now you will be getting pi over 3. Okay, done the first part, and then followed by second root. So the second root is square root negative 3, negative square root 3 plus 3i. So to get the modulus, use the same formula, bracket negative root 3 squared plus 3 squared. So square of negative root 3 is the same as square of square root 3. So I will be getting 3 plus 9. This result is same as previous. So I will be getting 2 root 3 as well. Okay, now for the argument of negative root 3 plus 3i. Okay, so for this argument, let's check the Argand diagram. So basically, our argument is counted from the positive x-axis. But then whatever you get it from the arctangent formula, that is the alternate angle. Alright, which means now we have to use pi plus inverse tangent 3 over negative square root 3. Okay, so here pi, the inverse tangent negative is same as negative of inverse tangent. So inverse tangent 3 over square root 3, we have found it just now, which is pi over 3. So I will get minus pi over 3. At last, you will be getting 2 over 3 pi. Okay, so this is how we get the two modulus and arguments. Alright, so of course for the result of B, it is just to show the points. So I will have to erase it. Right. So here are the points A and B. Right. So now D hence means use the part C result. So the both arguments and also modulus to show that the triangle OAB is equilateral. Okay, now when you go back to this, let's say here is the triangle. Right? So now how do we show that it is equilateral? Equilateral means that they will be having the same sides. Okay, all the sides are the same length. So since just now we have found the modulus of the square root 3 plus 3i and also modulus of negative square root 3 plus 3i. So this is basically the length of OB. Okay, this is the length of OB. This is the modulus. Right, this is the modulus of the second root. So now what we need to do is we just find the modulus of AB. So probably I can say let this be the B, then this is the OB modulus. Okay, this is the OA modulus because I have marked the AB on the parts B here. Alright, so now I need to get the length of AB. So if the length of AB is the same as the length of OB and OA, then it will be an equilateral triangle. So now length of AB Okay, or yeah, you can just write, no need to just write AB, that's it. We don't link it to the vector. So length of AB. Now based on the diagram, it is here root 3, here is another root 3. So that means it will be 2 root 3 when you refer to the Argand diagram. Okay, so now I will write it is 2 root 3. So from part B. Okay, so now since AB is 2 root 3, OA is 2 root 3, and OB is also 2 root 3. Okay, hence triangle OAB is equilateral because all same length. Right? So here better not to write in vector form. So just the length. Okay? So that is how we show the equilateral triangle. Now, number 6. Relative to origin O, the points A, B, C have position vectors given by 1, 3, 1 for OA, 3, 1, 2 for OB, and 5, 3, negative 2 for OC. Now A, using a scalar product, find the cosine of the angle BAC. Alright, so simply draw the angle first. So BAC. So from this angle, let's say the angle, let angle BAC be theta. Okay, so from this diagram, we know that we need the two vectors AC and AB. So now AB equals to OB minus OA, then 3, 1, 2 minus 1, 3, 1. So my AB is basically 2, negative 2, 1. Okay, next vector that we need in this calculation is vector AC. So it is same as OC minus OA. So my OC is 5, 3 minus 2 minus OA is 1, 3, 1. So at last, you will be getting 4, 0 minus 3. Okay, so now based on this diagram, right, AB dot AC equals to modulus AB times modulus AC cos of the angle BAC. So we have let the BAC be theta. So let just cos theta. So now AB dot AC. So 2 minus 2, 1 dot 4, 0 minus 3 equals to modulus of 2 square plus negative 2 square plus 1 squared, and the other modulus is 4 square plus 0 square plus 3 negative 3 squared, then cos theta. Alright, so for the left hand side, we need to do multiplication. So 2 bracket 4 plus negative 2 bracket 0 plus 1 bracket minus 3. So it's multiplication. Then for the right hand side, square out 2 squared plus 2 squared plus 1 is basically 9. Then 4 squared is 16. 16 plus 0 is 16. 16 plus 9 becomes 25. Then cos theta. Now left hand side, 2 times 4 is 8. The second term is 0. So 8 minus 3 is 5 equals to square root 9 times square root 5. Okay, square root 9 you can simplify it to 3. Square root of 25 is 5 cos theta. So now from here, my cos theta is basically 1 over 3 because we can cancel 5 from both sides. Okay, So at last, this is our answer because the question is asking for cosine of the BAC and we have let the BAC be theta. So we should not find the theta but just leave the answer in cos theta. Okay, so that is the complete solution for A. Now let's move on to B. Hence, again, hence means use the previous answer to find the area of the triangle ABC. Give your answer in simplified exact form. Alright, so now let's go back to the diagram. Now, let's say I join C to B and this is my triangle. Okay, so we have found the cosine theta and now the area of this triangle is half modulus AC modulus AB sine theta. Okay, that is our area of triangle formula. So I will write area of triangle ABC equals to half modulus AB modulus AC sine theta. Okay, but now you should understand that just now we have found cos theta is 1 over 3 and you need to leave your answer in exact form, which means you shouldn't get what is the theta from the calculator. Okay, so now use the right angle triangle method. Cos theta is 1 over 3, which means it is adjacent over hypotenuse. So adjacent is 1, hypotenuse is 3. So which means the opposite side is going to be square root of 3 square minus 1. And I will be getting square root 8. Okay, so now here is going to be half modulus AB. Okay, modulus AB is the length of AB, which is square root modulus AB is square root 9, which is our 3 from the previous calculation. So here is 3. Modulus of AC from the previous calculation, right here, modulus AC is going to be square root 25 is also 5. So here is going to be 5. Sine theta from this triangle is opposite over hypotenuse, which means it's square root 8 over 3. So square root 8 over 3. So now the 3 will be cancelled off. Okay, and simplify. So half times 5. Square root 8 is, now you see, square root 8 is square root of 4 times 2. So it becomes square root 4 times square root 2. And at last it will be 2 square root 2. So here I will get 2 square root 2. Now with this, we can cancel the half and the 2. So at last, the answer will be 5 square root 2. Okay, that is our exact area of triangle ABC. Okay, so now let's move on to the next question, number 7. The variables x and theta satisfy the differential equation x sine square theta dx d theta equals to tangent square theta minus 2 cot theta, where the theta from 0 to pi over 2 and the x is greater than 0. Now it's given that x equals to 2 when theta equals to 1 over 4 pi. Now first part, show that differentiate cot squared theta with respect to theta equals to negative 2 cot theta over sine squared theta. Now, given that you may assume without proof that the derivative of cot theta with respect to theta is negative cosec squared theta, means that we can just direct use this result. Okay, differentiate cot theta equals to this result. So now, to differentiate cot squared theta, so I will move the square to the outside. Okay, so it becomes square of cot theta. So when we differentiate square of cot theta, you bring down the 2, rewrite the cot theta, degree becomes 1, and now you differentiate the cot theta. So when you differentiate cot theta, the answer is given, which is negative cosec squared theta. Okay, this is our differentiation. So the negative 2 will be combined. Then now when you look at the question here, you need to show cot theta and then sine squared theta. So remain the cot theta. And then the cosec squared is basically 1 minus sine squared theta. So when I combine all the terms, you will be getting negative 2 cot theta over sine squared theta. So this is how we show cot squared theta equals to this rational function. Okay, so now B, solve the differential equation and find the value of x. So this is first part, this is second part. When theta equals to pi over 6. So now we need to solve the differential equation. So let me copy the question first. X sine squared theta dx d theta, x sine squared theta dx over d theta equals to tangent squared theta minus 2 cot theta. Right. So now when we need to solve the differential equation, we need to separate the variables. Right. So now since the right hand side, these two terms in terms of theta means that I will move the d theta to the right side and keep the x on the left hand side. Okay, move all the data to the right side. So now I will get x dx equals to tangent square theta minus 2 cot theta over sine squared theta d theta. Okay, so this is how we split the variables. Now followed by integration both sides. So for the left hand side, you can easily integrate it, but for the right hand side, we need to simplify first. So I will integrate once I have simplified the right hand side. So now the tangent squared theta can be split it into sine squared theta over cos squared theta, then minus 2 cot. Okay, I will remain the cot theta here because we know that when we differentiate cot squared theta, it will be negative 2 cot theta over sine squared. So which means if I integrate, okay, so if I integrate the right hand side with respect to theta, I will be getting this result. That's why I will keep the cot in my working. Right? So here I will keep the cot. I will not change the cot to cosine over sine. So I will keep the cot. Alright. So then I will multiply by 1 over sine squared theta at the back. So because I want to simplify the first term. So now from here when I multiply first term sine squared theta over cos squared theta with 1 over sine squared theta, basically I'm getting 1 over cos squared theta. Minus, then here I will combine back. It will be 2 cot theta over sine squared theta. Okay, so now 1 over cos squared theta is basically secant squared theta. Then minus 2 cot theta over sine squared theta d theta. Alright, so now this is the simplest form before we integrate. So now I will integrate left hand side x dx. It becomes x squared over 2. Then the right hand side when you integrate secant squared theta is basically tangent theta. Then for the second term, I will get the answer from previous part, which is our cot squared theta. So I will just write minus. Okay, it is not minus because here is already minus. You are getting positive cot squared theta. So here should be positive. Alright, and followed by plus c. So that is our first part. Now find the value of x when theta equals to pi over 6. So I will rewrite this, x squared over 2, so this one done, equals to tangent theta plus cot squared theta plus c. So when theta is pi over 6, now wait. Solve the differential equation, so done, and find the values of x when theta equals to pi over 6. So when theta equals to pi over 6, right? So let me check. Okay, now you have to be careful with this. Find the value of x when theta equals to pi over 6. So when you look at here, right? If I just write theta equals to pi over 6, I will have two variables, the x squared and also the c, because I only have the theta, which means now before we solve this part, so basically the first part is not solved yet, okay, because we still need to find the c. Alright, so now what to do is basically you need to replace the values over here. So when x equals to 2, theta equals to pi over 4, then that will be the solution of the first part. Right? So our first part is not done yet. So now I will write x equals to 2, theta equals to pi over 6. Then from here we need to find the c. Right, so I will get 2 squared over 2 equals to tangent pi over 6 plus cotangent. Wait, let me check back. Okay, mistake. Theta is pi over 4 when x equals to 2. So it's not pi over 6. Pi over 6 is next part. So here, pi over 4. Alright, so 2 squared over 2 is basically 2. Tangent pi over 4 is 1. The cot is basically 1 over tangent. So this is same as 1 over tangent pi over 4 squared. That means tangent pi over 4 is 1. So 1 over 2, 1 squared is still 1. Alright, so this is how we get it. Then plus c. So from here, our c is 0. So once you get the c, then this is the solution for the first part. Alright, this is the solution of the differential equation. So now with this solution, now we need to answer the second part, which is find the x when the theta is pi over 6. So when theta equals to pi over 6, right, x squared over 2 is tangent pi over 6 plus cotangent squared of pi over 6. So your x squared will be times the 2 to the right hand side. Tangent pi over 6 is basically root 3 over 3. So the cotangent is going to be inverse of root 3 over 3. So it's going to be 3 over root 3, then squared. Okay, so now let's check the question. Just find the x means that we can leave our answer in the decimal. Okay, make sure it is 3 significant figures. So from here, I will get x is 2.67. We do the square root. Alright, that's the solution for this question 7b. Okay, so now let's move on to question 8. The diagram shows parts of the graph y equals to sine root x. This is a sine root x. the part of the curve intersects the x-axis at the point x equals to a. Right, here is the point. State the exact value of a. So this a happens when the y equals to 0. So now 0 is sine square root x. Okay, so now when x equals to 0, your x equals to a. I will write this is a. So from here, sine square root a is 0, which means your sine graph, right, the square root a will be 0, pi, and 2 pi. So your a will be 0, pi squared, and 4 pi squared. Now let's check the interval. Okay, so from here, obviously it is not 0, and from the graph, this is the second intersection point. The first intersection point is 0, then the second intersection point is the a, which means now your a is going to be pi squared. Okay, that is the second value when it is 0, when the y equals to 0. Now b, using the substitution u equals to square root x, find the exact value of the shaded region in the first quadrant bounded by the parts of the graph and the x-axis. So from here, the graph is basically defined, the area of the region is counted from x equals to 0 until x equals to a. So we need to integrate the y from x equals to 0 until x equals to a. And the a is basically pi squared. So now our area equals to integrate from 0 to pi squared sine square root x dx. Okay, so now it's given the hint, use u equals to square root x. So when u equals to square root x, firstly we need to get the du dx. So du over dx, this square root x is basically x degree half. So when we differentiate x degree half with respect to x, it will be half x to the power of negative half. Or I would say that it is 1 over 2 root x. Okay, and now we need to get dx. So here is du over dx. So now your dx is going to be, your dx is 2 root x du. Okay, so you move up and this 2 root x move to the left hand side. So at the same time, your root x is u, the square root x. So I will get 2u du. That is our dx. And don't forget to change the limits. So when x equals to 0, your u is square root 0, which is 0. When the x is pi squared, your u is square root pi squared, which is pi. Okay, so from here, I will change my integration to 0, from 0 to pi. Then sine square root x will be u. Then my dx becomes 2u du. Okay, so from here, I will rewrite. Okay, here becomes 2u sine u du. Now, it becomes multiplication of two functions. First is 2u, second is sine u. So this integration must be solved using integration by parts. So now I will let, okay, from the by parts formula supposed to be u and dv dx. So now since 2u is already there, I will replace the u in the formula by w. So let w be 2u, then the dv over du be sine u. So now my dw over du, according to the integration by parts, it will be 2. Then the v is to integrate sine u du. So integrate sine u du is negative cos u. Right? So now I will rewrite my area is going to be UV. Okay, the original formula was UV, so now it becomes WV. So I will write negative 2U cos U with limits 0 pi minus integrate V du dx, or now becomes V dw over du. So it becomes negative 2 cos U du. Okay, it is integration by parts. So now, don't forget the limits. So now replace the u by pi. I will get minus 2 pi cos pi minus, when the u equals to 0. But since minus 2u, so when you multiply the minus 2 with 0, it's already 0. Okay, so then now for the next part, it's going to be negative, integrate negative 2 cos u. So the negative 2 becomes plus 2, left cos u. So when you integrate cos u, will be sin u. Right. So now cos pi is minus 1. So this is minus 1. Right. So minus 2 pi times minus 1 is basically 2 pi. Then plus 2, replace the u by pi. So I will get sin pi minus sin 0. So for your information, sin pi is 0. Okay, sin 0 is also 0. So which means final answer is 2 pi. Okay, that is how we solve the area of the shaded region. So we apply two methods here. Okay, now question 9. The diagram shows a semicircle with diameter AB. This is the diameter. Center O and radius R. So OA R, OB is also R because this is the diameter. The shaded region is the minor segment on the chord AC, and its area is 1/3 of the area of the semicircle, which means this is 1/3 of the area of the semicircle. The angle CAB is theta radians. Okay, now show that theta is 1/3 times pi minus 1.5 sine 2 theta. So we get the idea from here. Alright, the area of the shaded region is 1/3 of the area of the semicircle. So area of the shaded region is 1/3 of the area of the semicircle. Now, area of the shaded region is basically area of the sector minus area of this triangle. Okay, so now I will write area of the sector minus area of the triangle OAC. OAC. Sector OAC as well. Okay, sector OAC. Equals to 1/3 of the area of the semicircle. Right, so now area of the sector OAC formula is half R squared. Okay, here R squared, here R, here R. We need this theta, this angle. Okay, so for your information, OA is R, OC is also R. Right, OC is also R. That means these two sides are equal. So when equal sides means that the angle is the same as well. Therefore, area of triangle is pi. So pi minus 2 theta. This is going to be pi minus 2 theta. That is the area of the sector OAC. Then minus area of triangle OAC, formula is half R sine of this angle. So R sine pi minus 2 theta. Then equals to 1/3 area of the semicircle. Semicircle is half of pi r squared. Right, so from here we need to simplify. So you can cancel off all the half. That is our first step. Then cancel off the r squared. Here r is r squared, so cancel. So now you may rewrite pi minus 2 theta minus, so if you have no idea what is the sine pi minus 2 theta, you can just do expansion. It will be sine pi cos 2 theta minus cos pi sine 2 theta. Then right hand side is 1/3 pi. Okay, so now we need to show, see here theta is 1/3, then pi. So now we simplify first. Pi minus 2 theta minus, okay, so for your information, sine pi is 0. Okay, cos pi is minus 1. So due to this reason, 0 times cos 2 pi, it will be 0. Then minus minus is a plus. Then sine 2 theta equals to 1/3 pi. So now I open the bracket. It will be pi minus 2 theta minus sine 2 theta equals to 1/3 pi. Here is our 1/3 pi. Then the sine 2 theta should be with the 1/3. So means that now you need to get 2 theta as a subject. Then I will get 1/3 pi minus pi, then plus sine 2 theta. So 1/3 pi minus pi is basically negative 2/3 pi. Okay, let me check. This is theta. Okay, I did a mistake. I get the 2 theta means that I'm actually moving all the terms. I'm moving my 2 theta to the right side. Okay, when you see properly. So here is negative 2 theta. So I move it to the right side, and then I have to move the 1/3 pi to the left hand side. Okay, I overlook it just now. So it will be pi minus 1/3 pi, then minus sine 2 theta. So pi minus 1/3 pi is 2/3 pi, then minus sine 2 theta. Alright, so now I need to get the theta because the question says here theta. So I move down the 2. So when I move down the 2, 2/3 pi divided by 2 is basically 1/3 pi. Then the second term is 1/2 sine 2 theta. Okay, so but then when you look at the question here, we need to factorize 1/3 from all the terms. Therefore, I need to factorize 1/3 from the right hand side. I will be getting pi. Here is going to be 3/2 sine 2 theta because you factorize 1/3. So now, to get the given form, right, to get the given form, you should express 1/5 instead of 3/2 sine 2 theta here. So I will rewrite 1/3 bracket pi minus 1/5 sine 2 theta. So this is how we prove. Right? Sure. So I will write shown then. Okay, so That's the solution for A. Now B, verify by calculation that theta between lie at 0.5 and 0.7. So now I need to rearrange. So I'm going to move all the right hand side to the left hand side, and let it be f theta. So theta minus 1 over 3 bracket pi minus 1.5 sine 2 theta equals to 0. Then I will let my f theta be the left hand side. Okay, to verify the theta lies between 0.5 and 0.7, we are going to use a sign change rule later on. So now means that you need to count f 0.5 and f 0.7. Make sure both are having opposite signs. So since this is sine here, make sure you change the calculator, the mode of the calculator to radians instead of degrees. Okay, so the first value is going to be negative 0.126, and this is less than 0. Now we need to count f 0.7, that is 0.7 minus 1 over 3 of pi minus 1.5 sine 2 times 0.7. So here is going to be 0.116, which is greater than 0. Right? So from here, I will say, since f 0.5 less than 0 and f 0.7 greater than 0, there is a sign change. Hence, theta lies between 0.5 and 0.7. This is how we verify. Okay? So now C. Use an iterative formula based on the equation in part A to determine theta correct to 3 decimal places. Give the answer of each iteration to 5 decimal places. So the formula in part A, which is this. Right? So for the iteration formula, we need to add on the subscripts. So I will rewrite. Now I will get theta n plus 1 equals to 1 over 3 bracket pi minus 1.5 sine 2 theta n. So since we have proven that your theta lies between 0.5 and 0.7, you can let the initial theta be any values in between 0.5 and 0.7, or probably you can just take exactly 0.5 as your theta 0 initial theta, or 0.7 as your initial theta. But I will just take the middle value, which is 0.6. So from here, I will write theta 0 is 0.6. Right, from here, you will be getting theta 1, which is 1 over 3 pi minus 1.5 sine 2 brackets 0.6. Remember, calculate this correct to 5 decimal places stated here. Okay, and change the mode of the calculator to radians. So here I will be getting 0.58118. Okay, I will get 0.58118. Then now count the theta 2. So theta 2 will be 1 over 3 pi minus 1.5 sine 2 bracket 0.58118. So it will be 0.58833. Okay, when do we need to stop our iteration? Let's check here. Data correct to 3 decimal places. Make sure these 3 values are same as previous. So obviously they are not the same, then we have to continue. So data 3 is 1 over 3 pi minus 1.5 sine 2 bracket 0.58833. So it will be 0.58553. Okay, and again compare. So here when you compare, the previous value is 0.588, but then this data 3 is 585. But when you refer to the next value is 5, so we round up to becomes 586. It's still different from the previous. So now we need to continue one more step. Use the same formula and replace the data by the previous data. Now, our data 4 is going to be 0.58662. So now when I check this 5 and above, round up, I will be getting 587. But the previous is 586 if I round up. So now, continue for one more calculation. Alright, so now here you will be getting 0.58619. Now, when I check here, 619, right? Although they are the same, but previous one, because the fourth decimal place is 6. So when we round up, we should get 587 for the data 4. But then now, data 5 is 586. So it is still slightly different. Therefore, now continue for one more step. It will be 1 over 3 bracket pi minus 1.5 sine 2 bracket 0.58619. So at last, it will be 0.58636. Now, when we check, so first 3, 586. The next one is 3. So we just ignore this. That means it's same as the previous data. Therefore, we can stop our iteration and write down the final answer. So your data is basically approximate to 0.586. So this is our calculation. Right? Okay, so let's move on to the last question, number 10. So let fx equals to 4 minus x plus x squared over 1 plus x bracket 2 plus x squared. Now A, express fx in partial fractions. So 4 minus x plus x squared divided by 1 plus x times 2 plus x squared. So first of all, we have to check whether this is improper or proper rational function. So when you check here, the numerator is degree 2, the denominator highest degree is 3. Therefore, this is proper rational function. So since it's proper rational function means that we can apply the partial fractions directly. Otherwise, we have to perform the polynomial division before the partial fractions. So now, we write the denominator 1 plus x plus the other denominator 2 plus x squared. So the denominator is 1 plus x, numerator will be constant, which is the a. Then the denominator is 2 plus x squared, numerator will be a linear function, which is bx plus c. So now, by comparing to the left hand side, okay, compare to the left hand side, we need to multiply the denominator, and the first term must be multiplied by 2 plus x squared for the numerator and denominator. Okay, then for the second term, bx plus c over 2 plus x squared. So when you compare with the left hand side, we have the 2 plus x squared already. That means we have to multiply by 1 plus x. Right, so now since all denominators are the same, basically we can cancel off all the denominators and just write down the numerators. So these are the numerators, or these are the terms that we are getting right now. So now to get the a, b, c, all the unknowns, the easiest method is to let the factor be 0. So I will let 1 plus x be 0. Therefore, my x will be minus 1. So now replace x equals to minus 1. All the x, okay, in this previous step. So I will get 4 minus 1 plus minus 1 squared equals to a bracket 2 plus minus 1 squared. Now, since I let this 1 plus x be 0, means that the bx plus c times 0, you can just ignore because it is 0. So now for the left hand side, you will get 6. Right hand side is 3a. That means our a is 2. Next, okay, we supposed to let this 2 plus x squared be 0, but it will not be 0 all the time because x squared is non-zero. I mean, x squared is always 0 and above, right? So when you plus with 2, it will be 2 and above. So now what to do is, we let x be any other values. Let it be 0. So when I let x be 0, my left hand side will be 4 minus 0 plus 0. It is a 4. Right hand side, it will be a bracket 2 plus 0 squared is 2 plus b times 0, no more. So just left c. Then 1 plus 0 is 1. Okay, so now replace the a. So 4 equals to 2 bracket 2 plus c. So from here, 4 equals to 4 plus c. Therefore, the c is going to be 0. Now, found two unknowns, a and c. For the b, you can let it be any other numbers. I will use a smaller number, which is 1. So left hand side becomes 4 minus 1 plus 1 squared equals to a bracket. Now the a I will replace by 2. Okay, I will direct replace it by 2. Then 2 plus 1 squared plus b times 1. So it's b. The c is 0. No more. Bracket 1 plus 0 is 1. So from here, left hand side is 4. Right hand side, 2 plus 1 is 3. 3 times 2, 6. Then plus b. So my b is minus 2. Okay, let me check. Any mistake? Okay, there is a mistake here when I replace. When I replace my x by 1, so 1 plus 1 is going to be 2. This is 2b. Right? So here is going to be 2b. It's not 1b. So my 2b is 4 minus 6. Therefore, 2b is minus 2. Hence, my b is minus 1. So once we have found the three unknowns, a, b, c, just need to rewrite. And we'll be getting the partial fractions. So I rewrite now. 4 minus x squared over 4 minus x plus x squared over 1 plus x, 2 plus x squared. Equals to a, which is our 2, over 1 plus x, then plus bx plus c. So plus b x plus c is 0 over 2 plus x squared. But we don't leave our answer in this form. So the plus and minus becomes minus. Right, so I will just direct write minus. Then the plus 0 can be cancelled. So this is the solution for the partial fractions. Right? Okay, so last part, B. Find the exact value of this integration, giving your answer as a single logarithm. So integrate 0 to 4 fx dx equals to integrate 0 to 4. So our fx is the this function. Then we will just solve using partial fractions. So rewrite this 2 over 1 plus x minus x over 2 plus x squared dx. Alright, so now when we need to integrate the first term, you may factorize the 2, okay, and then 0 to 4, 1 over 1 plus x dx. I split it into 2 integrations, and for the second term, it's the same. I'm going to use the ln. Right, so when I differentiate 2 plus x squared, it's going to be 2x, but then here you are just getting x, so it means that we need to multiply another half, okay, in order to get the ln. So for the first integration, is going to be 2 ln 1 plus x. I'm going to combine the limits. Then minus the second integration is half ln 2 plus x squared. Now I combine two terms because they are sharing the same limits. So now replace the x by 4. I will get 2 ln 1 plus 4, 5, minus half ln 2 plus 4 squared, which is 4 squared is 16, 16 plus 2, 18. Then minus 2 ln, when my x is 0, it is 1. Then minus half ln 2 plus 0 squared is 2. Okay, and the question says single logarithm for the final answer. It means that we need to simplify all the ln. But before I combine, ln 1 is 0. Okay, so now to get single ln, we may use the formula ln a power b. I will better write here. Ln a power b is b ln a. Alright, so now I will move up the square, move up the 2. So I'll get ln 5 squared, then minus ln 18 power half. Then this minus and minus becomes plus. Okay, minus minus is a plus. The half move up, ln 2 power half. So now here becomes ln 25 minus, okay, the 18 you can change to, see, 18 is 9 times 2. Okay, when you take degree half, that means it's square root, which means this is square root 9 times square root 2. So square root 9 is 3. So 3 root 2. I will change it to ln 3 root 2. Then plus, this is basically ln square root 2 because 2 power half. Now, the next formula that I'm going to use is ln a plus ln b is ln ab. And at the same time, ln a minus ln b is ln a over b. It is a division. So now, the first term is divide, or I would say that I combine first and last term. Okay, so it becomes times. So 25 times square root 2. But second term is minus. Therefore, it's divide by 3 square root 2. Okay, and now the square root 2 can be cancelled off. Therefore, I will be getting ln of 25/3. So that is my final answer. Right? So that is the solution for this integration. Okay, so that's all for this video. We have completed this paper. Alright, so if you enjoy watching my video, do not forget, or remember to subscribe to my channel and stay tuned for more videos. Thank you. Bye.